Hi, human geographers. You are about done with topic 1.1 Introduction to Maps. Woo, go you guys. In this video, we are going to tackle this very last essential learning from topic 1.1. And you can see it says all maps are selected in information. Map projections inevitably distort spatial relationships in shape, area, distance, and direction. So we're really focusing on what are map projections and how do they really distort reality. So it's the main idea here, right, is that map projections are distortions. They are the way that a cartographer, which is the person who sits down and makes the map, it's the way that that cartographer takes this curved globe of the earth, right? The earth is a globe, it is a sphere. It's actually called a geode, which looks like this, right? This is kind of a rough outline of what the earth is actually shaped like. And so a map projection is the process of that map maker, that cartographer sitting down and deciding, how am I taking a ball and changing it and making it flat? Right? How do I kind of go through that metamorphosis, that transformation? And so that's where these distortions come in. And all maps are selective. They all have different purposes. There are hundreds of map projections out there. You don't need to know all, 150 of them, but you do need to know that they are created for different purposes. We're just going to look at a few of the major map projections and discuss their distortions and their advantages. But just know this is the main idea here, is that cartographers are not magicians, right? They have to transform this ball into something flat for us to see the map projection, and it gets distorted along the way. So one way that I remember the distortions, and I think this has helped students in the past, is to remember that map projections are sad, right? SADD. They're sad because they mess up. Every single map projection messes something up. So they are eternally sad. And here are the four things that they mess up. They mess up the shape of areas, the area, meaning the size, the distance between those areas, and the direction, right? So remember last video, we talked about absolute and relative distance and direction. And so map projections mess up those absolutes because they distort things. They are sad. So here's the first map projection that you got to know. This is called a Mercator, and this guy is old. The Mercator was made in 1569, and this was really at the height of the beginning of international travel between the kind of old world and the new world. And so it was initially created for navigation on the sea. Okay, that is the overall purpose of it. So, since it was created for navigation, the cartographer wanted to make sure that he sat down and that he maintained the direction and preserved those lines of latitude and longitude. Right? They want to make sure, that cartographer wanted to make sure that if somebody set sail from Spain to North America, that they would be able to do that with the Mercator map. The Mercator also does a really good job at preserving the shape of the continents. However, all map projections are sad. And so the Mercator messes up the area, the size of these locations. Now, something that you should always look at every single map projection is Greenland right here, right? It appears to be enormous. And Antarctica down here also appears to be enormous. And this is because what Mercator basically did was distorted the area near these poles, the North Pole and the South Pole, and think of it as like stretched out. And so the size of these locations that are high latitude, right, is very distorted. And I'll show you another example of how these locations can be portrayed. That's the Peters equal area. So the Peters equal area was made hundreds of years later. And the Peters map was basically made as a rebuttal to Mercator's map to say, you know what, you really took away a lot of the area, the size of the land masses on the globe, on the earth. And we want to correct that by giving them their equal area, right? We want to make sure that they are accurately depicted in area. And so that's its advantage, is that these land masses, these continents are projected accurately in terms of how large they are, their size or their area. And so what actually happens here is many countries or land masses are returned to their rightful size. And now I know that this is like kind of bizarre to think about, but when a country or a landmass is small on Mercator's map, they appear to have less influence in the world. Now that they're on the Peters equal area and they retain their actual size, then they may gain some of that geopolitical influence back. Now, like I said before, when you're looking at these map projections, you need to check out Greenland, right? And so Greenland looks completely different here, right? It is right here. And so let me go back. This is what Greenland looks like on a Mercator. This is what it looks like on a Peters, right? Do you see the difference there? Something else that you should look at in the differences is the size of Africa, the continent of Africa, right? So here it is on the Peters, there it is on Mercator. So you see this massive difference of how, Russia, Scandinavia, these kind of high latitude areas got distorted to be much larger. And now when we look at the equal area, we can see that South America, Africa, these Southeast Asian islands are much larger than they actually appeared. Now, here's the thing though, the distortions. The shapes are very inaccurate, right? The shape is all off. And we see some sort of kind of like vertical stretching, again, stretching happening near this red line, which is the equator. But again, all maps are selective. They're going to distort something. So, what is it going to be? What's the intention of the cartographer? This is so interesting to look at. This is the black is the Mercator projection, and the green is the Peters equal area projection. So look at how much difference there is between the two. This is just another perspective. You can see, Africa versus Greenland. On a Mercator, if you like trace Greenland and try to put it over Africa, this is what it ends up looking like. But this is the reality. This is the actual size of Greenland overlaid on the continent of Africa. So you can see again this major distortion. Okay, the Robinson map or Robeson map. This is the ultimate compromise. Okay, I showed you a Mercator, which was very purposefully drawn for navigation. I showed you the Peters, which was very purposefully drawn to show the equal size or area of land masses. And so now here we are with the Robinson map. The Robinson has no major distortions. Now, when I say that, let's pop over here to the disadvantages because everything is slightly distorted. So, shape, area, distance, direction, sad. All of those are distorted a little bit here on the Robinson map, but as I said, it's kind of to geographers, it's seen as this compromise to kind of minimize all of the issues that both the Mercator and the Peters have. Now, there are, like I said, hundreds of other map projections. This one is called an azimuthal, and it's like you are kind of standing on top of the North Pole and kind of looking down at the Earth. You can see right here is North America, South America, Africa, continent of Africa. Down here is Australia, right? This one is called a conic map projection. You can see it kind of takes a different shape than you're probably used to. And this one here is called a fuller map projection. They all have their positives and negatives, right? Like this fuller map projection was created because the cartographer wanted to maintain the actual area of all of these continents, these land masses. And so, what this cartographer ended up doing was splitting up all the oceans, right? But this is a perspective that you've probably never seen before and is going to be difficult for you to really look at if you're trying to find a country quickly, if you're not familiar with it, right? So they all have different purposes, right? And that's the main idea, right? What is the point? All maps are selective. All of them distort the Earth's surface and land masses because you cannot go from a ball to a flat surface. You cannot go 3D to 2D without having something messed up. Okay, so that's map projections for you. I'm just going to scroll back here so we can look at the essential learning and the objective again. All maps are selective in information. Map projections, which is when those cartographers create a two-dimensional map based on a three-dimensional globe, they end up distorting spatial relationships, and those distortions are SAD: shape, area, distance, and direction. All right. Let me know if you have any questions in class.